Hello, welcome back again to the channel. On this video we are going to discuss again problem from geometry in figures as you can see here on the blackboard. So we are going to discuss geometry in figures 1.8. It is about the Michael point or the Michael circle. So here is the setup of the diagram. We have an arbitrary triangle, okay, and then pick 3 points on the sides of that triangle. So let's say we pick this, this, and that. Okay. So using these 3 vertices, we make a circumcircle, and then using that vertices, we make another circumcircle, and then the claim is that the intersection of these 2 circles there, together with the 3 other points here, 3 other vertices here, is concyclic. They form a cyclic quadrilateral. Okay, so that's what we are going to prove here. So if you want to try it first, and I suggest that you do so, so just pause the video for a while, and then you can continue, and then you can come back here and see the solution. Okay, so give it a pause now. Okay, let's solve this problem. Recall that on the previous GIF, geometry in figures, we have these 2 following results. The first one is the inscribed angle theorem. So if we have 2 angles facing the same arcs, then they are in the same measure, right? And then the converse of this statement is also true. If we have a quadrilateral such that the diagonals and the 2 sides of the quadrilateral from the same angle. Let's say we have something like this, for example. Okay, if it turns out that this angle equal to that angle, then we know this quadrilateral is concyclic. They all belong to the same circle. So that's the converse of this statement. And it is also advisable to try to prove the converse of that result. Okay? And the other one, we also know that if we have a quadrilateral, cyclic quadrilateral, then if we take the 2 opposite angles, they are add up to 180 degrees. Or the 2 opposite angles are complementary, supplementary to each other. Okay? And the converse is also true. If we have some random quadrilateral such that that guy plus that guy is 180 degree, then there must be a circle that passing through all the vertices of that quadrilateral. And we are going to use this fact to show that these 4 points belong to the same circle. Okay? So let's continue with the problem. So notice first that these 4 points belong to that same circle. So we have this result and we have also that result. In particular, if we look at this angle, let's call it alpha, then the opposite of that alpha will be the supplement of alpha. So they add up to 180 degrees. Let's call this as beta. So alpha and beta, the sum of alpha and beta is 180 degrees. Okay? Now let's do some angle chasing. Okay? Since this is a straight line, then certainly this one is the supplement of alpha, which is beta. So that's going to be beta, right? And this is also the supplement of beta, which is alpha. Okay? Now, connect this point to that other point. Since these 4 points belong to the same circle, that circle, this guy is a cyclic quadrilateral. So therefore, the sum of the opposite angles is equal to 180 degrees. Since this angle is beta, so that other angle must be the supplement of beta, which is alpha. So that's alpha. And since this is a straight line, that's going to be the supplement of alpha, which is beta. So therefore, now we have a quadrilateral where the two opposite angles are add up to 180 degrees. Therefore, there must be a circle that passing through all these vertices. So we prove it, the existence of this Michael circle. Actually, I think it is more common to say that this particular point is the Michael point. That's M, right? Okay, so that's all for 1.8. We will continue again on the next problem on the next video. See you again. Bye-bye.